Hello everyone, so my name is Chris and I'm going to be talking to you about environments inside a Kubernetes cluster. But before we start, let me just give you a quick intro to who I am. I am the VP of Product here at Humanitec. Why is someone from the product space talking to you, or a room of engineers, about a very technical part of the infrastructure? So let me just give you some background so that you will believe that I actually know what I'm talking about. So I started 10 years ago as a software developer, and I've worked on everything from waste management site software through to banking software. I also ran a high-performance computing group for a while at a large insurance company in London. I then switched into product. I moved to Google and I built an internal platform for building apps for Google engineers to speed up some of the app development process they were doing. I then spent some time in startups, and now I'm here at Humanitec, and as Casper said, we are building an internal development platform for you, so that you can have a more and a better experience building apps for Kubernetes. So, let's jump straight in. Let's start off with the basics. What is an environment? So, basically, the environment is everything that is not your software. So hopefully everyone's got the idea, but let's just jump through it. So your software is made up of things like source code. Maybe it's made up of binaries, possibly some kind of assets. These could be images, sounds, HTML files, whatever. And as we talk about Kubernetes, it's also your container image. And everything inside your container is your software. Okay? Things that are not your software. So this is a much bigger list, as you're probably aware. Configuration. Configuration is not your software. It's how people configure your software, so it doesn't belong to you. The operating system generally doesn't belong to you. Also, the hardware doesn't belong to you. Other things that don't belong to you often include databases. Those are often managed by other people, and you need to play nicely with them. Also, the network usually doesn't belong to you. So as you can see, there's a large pile of things. Dependent services. Data is something that a lot of people forget. Data doesn't belong to you. Data changes depending on what environment you're in. If you're running on your machine, you may have some small test data. If you're running in production, you might have terabytes of data. And that's a little different, right? So there's different data in different environments, and it's not your software. It's something that you have to deal with when you're managing environments. Security policies is another one which people often forget. On your laptop, you're the admin, you're the boss. When you're running production, you probably have no more rights than a normal user using the system. So those are different things in different places. And there's many more, but for the sake of brevity, let's move on. So, in general, you have more than one environment, right? I just want to take you through a list of the environments, and we'll just talk very briefly about what they all are, because it's going to be relevant when we talk about how to manage environments in Kubernetes. So, local development. So this one's really easy. This is your laptop, your workstation. It's a machine you own, and you can do whatever you want with this. No one else in general is working on this, so it's a private, non-shared environment. Then we have, usually, most companies have a shared development environment. If you're building with a team, you often want to have somewhere where you can all collaborate and have a common version of the truth in terms of what your software does. Once you've got through a shared development environment, then you might want some kind of staging environment. What is a staging environment? It is where you say, right, okay, we want to calm things down, and we want to make it look as much like production as possible, so that when we do deploy to production, we don't get any nasty surprises. And then finally, you do have your production environment, which is where your users are. So this is where money is made, this is where things are shared, likes are generated, or whatever your company happens to do. So those are kind of your standard environments, and I think most people can probably recognize them. I'm sure, can we just have a show of hands? Everyone is familiar with these environments, right? Yes, no, yes, yeah. Okay, that's good, like 80% of the room. That's pretty good. We have other environments though. For example, feature development environments. So what are these? Well, if you're working on something with another person in your team, and you're going to break a lot of stuff, you still want to collaborate, but you probably don't want to have to shift code around and try and build everything on each other's machines. It'd be great if you had a feature environment where you could work in isolation, but collaboratively. So it's still a shared environment, but it's not you're not affecting everyone else in your team. You might also have a testing environment. Any QA people here? One person, excellent. 2 people, we have 2 QAs. This is very important to QAs because you want to be doing testing, but maybe staging is too busy to do proper testing, and probably the shared development environment is too unstable to do proper testing. So maybe you need a testing environment. Maybe you also need a UAT environment. This is a little bit old school. It's not very popular these days, but maybe your business users want to say yes. I agree that this software does what I need it to do, and so we allow you to put it into production. And then the last one that most people forget about is disaster recovery. Just quick straw poll. Who in a company has a disaster recovery environment? Not very many. A lot more of you know about environments than actually have disaster recovery environments. I guess with replication in the crowd, this is less important. Was that a question? Or?
Yeah, question. Why use disaster environment?
Sorry, which one?
Disaster recovery.
The UAT. Oh, disaster recovery. So if you run your own systems in your own data center and something bad happens to that data center, you probably want to be able to switch to another data center somewhere else.
Is backup?
It's backup, yeah. So if your main production environment goes down, you have some way of being able to recover into a new environment.
Fine.
Yeah, cool. But all of these make sense? Great. So let's just quickly categorize them. Oh, sorry. Let's talk stability. Obviously, local is the least stable, and hopefully disaster recovery is the most stable. Otherwise, you've got problems. So let's talk about categorizing them. Software moves kind of from left to right, and we start off in a non-shared environment. So local developments are non-shared environments or private environments. We then move through shared development environments, these 4, and lastly we end up with our production environments. For the purposes of this talk, we're going to worry about the orange ones, our shared development environments. Okay? So we're going to say, how do you actually manage this in or with Kubernetes clusters? So let's just remind ourselves about what Kubernetes environments are. So we have 2 sets of things in the Kubernetes environment. We have internal stuff, internal to Kubernetes, and we have external stuff that's external to Kubernetes. So for example, anything that is a Kubernetes resource is pretty much an internal thing. Plus, if you're doing something like running a service mesh, that configuration can be described as being internal to your cluster. Then we have a load of external things, which are things which are generally not in your cluster. Not necessarily true, you can run databases in Kubernetes clusters, but in general, these are things which are probably running outside. So if you're on GKE, for example, you may be using Google Cloud SQL to host your databases. So that's not in your cluster. Things like networking, things like DNS, these are all things that are external to your cluster. So why is this important? Well, the internal stuff is something you can manage when you're managing an environment in a cluster. External stuff is stuff you have to manage in addition to the stuff you're dealing with in a cluster. So we'll have a look at that. So what is the most naive way of setting up these environments? Probably clusters. So we create one cluster per environment. Everything is fantastic. We design our shared development environment, our staging environment, and we shove a cluster in, and of course there's some nodes in there, and everyone is happy. Except that the internal stuff is fine. We're managing internal resources, but external stuff is a pain, right? If we have an external database that needs to be accessible by both environments, you need to potentially configure your network twice, once for each cluster. And imagine then if you want to spin up a feature cluster, right? You've then got to wait for the cluster to spin up, right? Even if it's fully scripted and automated, those things don't turn up straight away. If you spin up a GKE cluster, that can take several minutes to become available, and you then have to potentially configure your network so that the resources of that cluster can access your database, can access third-party APIs. You've also got this problem that you have these 3 nodes, say in the one environment and 3 nodes in another. Most development environments are pretty low traffic. Probably you're not going to make optimal use of all of the compute resource. Plus you have a load of overhead. You've got to pay for a master node for each cluster, and potentially you're not getting good packing in your nodes themselves. So it's good, it kind of works. Some people do this. If you have very strict isolation requirements, this works really well. But there's a lot of extra work. So, can we do better? Well, this is what most people think about when they think about clusters in Kubernetes namespaces. So everyone familiar with Kubernetes namespaces? Yeah, lots of nodding, fantastic. Basically, you have a cluster, you define some namespaces, and you have nodes which have workloads which are running in 1, 2, 0 namespaces, depending on your setup. So let's just look at an example. So if we have a cluster, we have our two environments, and we have a team who's pushing service A. Service A is something which we want to deploy to a shared development environment. Fantastic, that's running in there. Maybe then we want to test it in shared development. Great, we now want to send it to staging. We then promote it to staging. Everything's fantastic. Maybe then we want to push a new update to a shared development. That's fine. Because we've got namespaces, these two services don't conflict, everything's fine, everything is nicely maintained. In practice, you probably have some other stuff running in your cluster, maybe a cert manager, maybe you have Tiller, maybe you have some other stuff. These things are all running on nodes, but we're getting some good packing because we can run services from both environments on a single node. So maybe we're getting better utilization of our resources. We don't have to repeat Tiller for every single environment. This is great. Also on the external stuff, we have a database, we have third-party APIs. We don't need to configure our network multiple times. You can configure it once for one cluster, and off we go. We add more environments, effectively new namespaces. Great. We don't have to configure anything external to our system. So this is much more flexible. This is great, actually. Most people do this. This is a fantastic idea. But obviously the talk is not over, it will be very short, so therefore there's obviously a complication. Now, what happens if suddenly you have more than one service that you're deploying, or you have multiple teams also working? It will look something like this. You have two teams, they're both pushing to the same shared development environment. Seems very reasonable now, and then they push in addition to their shared staging environment. But of course, everyone knows that you get conflicts. If service A depends on service B, and service B has a breaking change, then service A will stop working when the update to service B is pushed. Standard stuff. If you have two teams, you could probably say, hey, you've broken my service, let's chat, let's roll back, let's fix, let's move forward, right? That is great. But what happens if instead of having two teams, you have 26 teams? So we have all the way down to team Z, developing service Z. Now, in practice, these services are also not single services. Probably you have like 50, 100 microservices, and you have 20 teams. So each team is pushing multiple services. This is happening all the time. And you are very likely to end up with a situation where this environment is constantly broken. Is this something that's familiar to anybody in this room? Like a few people? Excellent, right. This is obviously not a good approach because you spend most of your time fixing broken environments rather than writing code. So can we do something about this? So kind of a solution would be for every single team to have their own private shared development environment, right? Because that means that you don't end up with conflicts in your shared development environment, which means everything is great, right? Well, if you're paying attention, you'll just know that you just push the problem down the line, and it's slightly harder to resolve problems in staging because you're one step further down the line. So what if we could do something a bit cleverer? So let's look at, we'll take one little example for one team, one private shared development environment for a particular team. So this team develops service C. Now, they set up their shared environment with the services from teams A, team B, and team D. Fantastic. Now, if you were running this kind of in a manual process, you would have to go and talk to team A and say, hey, can you deploy this into my environment? Or you'd have to go and find their charts to deploy into your particular environment. Maybe this is a bit complicated. What if we could do something a bit cleverer and say, well, actually, our shared environment is actually going to be basically staging, just with the stuff that we wrote in this environment. So we kind of pull in services from staging into our shared development environment so that we can then develop against a same version of what's going on. And also, we know that if the integration works, then we can push to staging without any problem, because we've already tested it with everything that's in staging, right? That would be great. So let's figure out how to do this. The next bit, the service mesh, comes to our rescue. So everyone familiar with the service mesh? Probably. Yeah, cool. So service mesh basically means you can route requests between arbitrary versions of services. And if you do this in a clever way, then what you can do is actually get a nice little setup, like we had here, but we can route traffic that would normally be going from service C to a local copy, and actually instead route it through to the actual staging environment. So what you can do is you can run one copy of your code in a staging, in a nice, well-manicured environment, but you can pull it in for purposes of you doing work in your development environment. So everyone has their own staging environment, but you get this advantage that everything is kind of stable and everything is kind of well structured. So that's cool. And in principle it works. There is a little problem. Remember, this problem is to solve large scale teams. So you've got 50 teams, 20 teams, whatever, pushing 100 microservices. You will still get some kind of conflict. So let's just talk through. I just want to explain to you what that conflict is, and then we'll talk about the last of the step you need in order to clean this all up. So we have 26 teams, all pushing their different services. Let's focus on 3 of them. All of these services dependent on each other. That's great. So let's say Team A, Service A, based in Berlin. They test. So they're running this situation where they've got version 2 of their service, which they don't care about, but they've got version 1 of Service B, version 4 of Service Z. They test it in their shared development environment. Fantastic. They push to staging. All great. All updated. Everyone is happy. They go home. Service B, these guys are based in London. They do the same thing. They're like, okay, great. Currently, we've got version 3 of Service A. We've got version 4 of Service Z. It's all working. But there's a football match on, so rather than deploy, they all go to the pub. Okay? Then you've got Service Z, based in New York, or maybe it should be Service Z in New York. They do a test of what's currently in staging, and so they have got version 3 of Service A, and they've got version 1 of Service B. And they're like, great, everything works, we haven't broken anything, let's push and let's go home. Now, the London team get back the next morning. They're really sad because their team was lost, but they say, hey, let's cheer ourselves up by deploying our service because that'll make us feel much better. So they go ahead and go, right, we did the test last night, everything was fine, let's deploy. And of course, there's been a change overnight. The New York team deployed a new version of Service Z. Now, the tests are not valid, they do the push anyway, and guess what? The service breaks. So now they're sad about the football result, and they're also sad about the fact their service isn't working. So this kind of thing might seem a little esoteric, but you can imagine this happening in practice quite easily. If one service has a deployment time, like a CI process that takes 40 minutes, say, and another one has, or a test suite that takes 40 minutes, and another one has a test suite that takes 2 minutes. If they are both deployed at the same time, the one that has the 2-minute test suite will win, and the one that has the 40-minute test suite, the test might all pass, but then you do the deployment and everything fails, right? So this is something that can happen in reality, and probably happens more often than people want to give credit for. So this is a real problem, but there is something we can do about this. And for the 2 QA people in the audience, you'll be happy that automation is part of the solution. We should revisit some of these environments that we were talking about before. So we've been focusing mainly on the shared development and staging environments, but there's this testing environment, right? What about we use this testing environment to actually give us a sanity check before we can go into staging? I'll explain what the story there is. So the testing environment we can actually pull out, and we can get, say, a version using the service mesh. We don't actually need a real environment. We can get what's running in development, and what's running the staging. Or you could deploy and run it in an isolated cluster. If you want to be super precise, maybe that's the way to do it. And you have one cluster which is dedicated to churning between environments. So you get updates from dev, you get updates from staging, and you run them in this isolated packets. Now, the trick here is not that you're running all of these things, but you have an automated pipeline that picks up deployments sequentially. So, for example, it would run service A, and then it would run service Z, and then it would run service B. So you're not trying to do them all at the same time, you're queuing them up and effectively gating them. And effectively, these are just different charts, right? So you just queue up your charts and you run one after another and see how they go. And because you're queuing them up, at a point where things fail, you can reject that. So that change, which the developers may have never tested the combination that now exists in staging, but by the time their deployment is queued up and hits the front of the line, maybe the environment is no longer compatible and you end up with a broken deployment. Which is fine, because then you can reject it at this stage and you haven't affected your staging environment. So you get a message back to the team to say, hey, your deployment failed, you had some incompatibility compared to when you did your tests, and go and fix it. And so you've now got a much more stable staging environment. Make sense? Cool. So while we're talking about other environments that we've missed, feature development, basically this kind of works similar to the mini testing environment, except without the automation. So we basically take our little environment and we push in some local changes. We take what's currently in the shared development world and we can then test in that world. So we don't have to deploy everything that's in our shared development world. We can just deploy our changes and off we go. Yeah, so that's a kind of principle. You could think about this as a kind of reverse canary deployment. So if you think about it, you're kind of pulling the upstream environment into the downstream environment for the purposes of testing, as opposed to when you're doing a canary deployment, you're doing the other way around. You're pushing something from the downstream environment to an upstream environment in order to do testing. So reverse canary deployment. If you tie in this automation, then you end up with a nice solid kind of concept. So let's just jump through it. So we talked about environments being things that are not your software. So all the stuff you have to control, like everything that's happening around you. They're very important. I think we can all agree on that. Lots of strategies. You can do clusters, you can do namespaces, you can do fancy things with service meshes. There's a whole lot of other things you can do, which are applicable for very esoteric use cases. But this reverse canary setup is a very interesting approach, which is definitely worth looking at. And if you have an ephemeral, did I say ephemeral? Yes, ephemeral testing environment, which spins up, does your testing, and is a gatekeeper before you get to your staging environment, then you actually have reliability built in. And it becomes a very simple system for all developers to use. It just becomes part of the process, and you haven't got to fiddle around with debugging environments by hand. Great, so that was the talk. Thank you very much. Just quickly remind you that, as Casper said, we're hiring senior backend engineer, VP of engineering. You can visit that website there if you're interested or you know someone who is. And we're also looking for testers and people to give feedback on our internal platform. So do drop your name here, go to that link, scan a QR code, do whatever you want. But we'd love to hear from you, whether you just have expertise to share or whether you just want to get stuck in and give our platform a go.